video then we're going to look at how we can solve simultaneous equations using graphs. We've already looked at how we can use substitution and a couple of different methods, but sometimes you're given equations and have to create lines to solve them. So this follows on from the last video where we looked at how to actually plot a linear equation. This time we're going to be using two of them and working out the answer to a simultaneous equation. So how do we actually do this? Well, here's an example to start with where we've got 2y is equal to x plus 7 and 3y minus 6 is equal to 2x. So the first thing I'm going to have to do is plot these on a graph. Now I can't do that until I've rearranged them, and I need y's in their own and x's on their own. So to get the y on its own, instead of having 2y, I'm going to have to divide the left by the 2. And that means then I have to divide the right by the 2. So everything on the right has to be divided by 2. X divided by 2 is a half x, and 7 divided by 2 is 3.5. So now we've got that format to the equation we wanted from the last video. Y equals mx plus c. Y is equal to a certain amount of x's, half in this case, plus a number, in this case 3.5. I'm going to have to do the same here now and rearrange it, because instead of having y is equal to something, we've got this equation here is equal to 2x. So first of all, I'm moving the x to the other side because I want to make y the subject of the formula, as we always do in these cases in plotting a graph. Now I have to get rid of the 3, so I'm going to divide both sides by 3, ending up with 2/3 of x plus 2. And now both of these lines are in the format of y equals mx plus c, and that means we can plot them on a graph. So here's my graph, now my Cartesian graph with the two axes. I know that the 3.5 at the end of the first equation tells me it's going to cross the y-axis at 3.5, so I plot that on. And then the half gradient tells me that I'm going across 2 and up 1. So remember that if it's a whole number, then the number on top tells you how many y's you're going up, the number on the bottom tells you how many x's you're going up. So I've got those two lines and I can plot a nice line going through them. So that's the first line plotted. On the second line then, I'm told by that number on the end that the line crosses the y-axis at 2. So I plot another line at 2. And remember, as I always say, you should be doing these with little crosses in the actual exam and getting them nice and spot on. The 2/3 of x tells me that we have to go across 3 for every 2 up. So there's my 2 points. I join them up, and now you can see that the lines will actually cross at a certain point. And that is where the first equation is equal to the second equation. In other words, it's when the two y's are the same value. And it will be where the two x's are the same value. So essentially, you've got the solution to the simultaneous equation when you read these off, where x is 9 and y is 8, and we've solved the simultaneous equation by using a graph.